I have started to recording, and this session will be recorded. Just so everybody knows, we are beginning to discuss 12-factor manifesto, which is a link available on our website. You should read that, and we have just beginning to go over these 12 factors. Those key factors essentially are code base, meaning you put everything in the when you begin writing something, when you start creating something, you begin putting everything inside Git control. That's the way I like to think about. Put everything in control in form of a source code. You can put that in GitHub, Bitbucket, GitLab, whatever you feel like. And that's the first one. The second one is dependencies. So here, for example, on the right side of the window, we have a dependency on the gem called Rails in line number 5. We are specifying very clearly what do we need, 4.2.4 version of Rails. We are also specifying that we need the PG gem, which is the PostgreSQL gem, which will allow Ruby language to connect properly with the PostgreSQL database. And also, if you remember, the last time when we started creating this app, if you look at our history of the commands, you will remember line number 233. In that line, you will see that I have created the new Rails application, and this actually mentions the reference to a database, PostgreSQL. And the core idea behind this is that we are basically putting our foundation in such a fashion that we are able to have the same elements that we will like to see in production. We are using the same exact configuration, same exact dependencies, same exact things that we need on our laptop right here, right now to begin with as we begin developing something. And that's one way to think about is we are already taking steps to begin with to make sure that we have a consistent frame of reference as we go along from the initial developer beginning the project all the way to deploying it all the way end to end. Next one is configuration. We will store configuration in the environment to the extent possible so that it does not depend on the actual code. So basically, this is like referencing environment variables that you can put database strings, you can put credentials, all of that go along in the environment of that computer where it runs so that these elements can be abstracted away from the code itself. That was the configuration segment that I'm describing. And we will keep bringing up these ideas as we progress along. So I'm briefly going through them as we proceed. Next one is backing services, anything that you need something from the outside. For example, again, that Postgres. This is a service we need for our data structure to be deployed and stored and used. So we need a third-party service, and that becomes available to us from this same company, Heroku, heroku.com. They will give us a place where we can actually get a database. And so as you log in here, you will find that these guys actually provide us a free database also. So for every application, for example, just pick anyone. So this is an example application. You can just add specific components you need in terms of what capabilities you want to add on to a given application. This is not a real application. This is just a dummy placeholder for now. But I will illustrate the point where we actually create a database. And Heroku is nice in that they specifically give developers a lot of free resources. And the recently created unfortunate scenario is that they actually put our application to sleep for 6 hours unless you pay them money. And that's how they are making money. But that's okay. That I can understand that aspect. But it is still good for developers as they try to learn and deploy what it takes. So that's the scenario that is useful for them from a dev standpoint. From the further point I'm trying to illustrate was build, release, and run. So these are three clearly distinct stages. When you are building something, like for example, in the right side window, we are trying to build a sample application, and we will put that entire thing inside a Git commit, and then we can release it to a buddy for them to buddy test, or we can release it to a staging environment where it can be staged very effortlessly, very easily, without having to worry about, because we are already defining everything inside as to how the project gets deployed. And then we can take the same thing and run it in the final production mode. Another idea that is critically important to think about is the idea of process, which is in making processes stateless. And by stateless, I think I should maybe illustrate a point here. The point I'll try to illustrate is I'm going to switch my screen and see if I can bring up a whiteboard. Whiteboard coming up. And on that screen of sheet of paper, what I have is a pen I'm selecting, and then I'm trying to write this idea, which is I'm trying to describe this idea of stateless. I think you probably understand this very clearly already, but let us visualize something here. The idea of remaining, the application should remain stateless. The core idea is that anything that modifies or changes, so if there is a change here, so delta, any change that happens to something in the environment that needs a change in the app, that then the app itself is not stateless. It has become stateful. We would like to keep the application stateless, meaning any state changes, that things happen, things change. You want to keep them away from the app, keep something away, somewhere else. That else can mean something in a variety of contexts. So there is a chat request. I can ignore that one. Let's go back to our example of Facebook. So in the example of Facebook, when I log into Facebook, I see something and some people are posting. So anything that a user will post, say for example, I'm going to create a photo and I'm going to upload some photo. The moment I send something, that becomes a change of state. Another example would become when I log out. Let's say I log out, that's a change of state. When I log back in, that's a change of state. So anything this is happening when I'm logging in, logging out, anything like that, I think I forgot my password, but whatever. The idea is that anytime a state of a user changes, you want to keep things away from your app, but instead keep them somewhere else. For example, when a user logs in, you want to keep that entry in a database, and the database has to be away from the application itself. Another example was this idea that I was describing, in which a user will take a picture of something, say picture P, and the user wants to upload that picture to that machine here. So this is the application. The state of the application should not change. Instead, when the user uploads the picture, that picture should not only get saved here, but instead, I would rather have it erased from here and save it somewhere in, say, S3, for example. And then have that picture P sit here instead of sitting here. And the idea behind using it, putting it that way, makes the app stateless. What does that really boil down to? Let us understand that. And the idea essentially is that, imagine if this machine dies, like dead, and so another machine has to take over. The machine can very easily take over if you have the machine and application itself stateless. And so that machine can come back in its place, another machine can take shape and create the same application and remain, since it was stateless, because your picture itself is actually away in S3. And so the user, that next time user U, when he or she comes online, they expect to see the picture showing up on the same website. That will be possible because the application itself does not store the picture. The picture actually gets rendered from here, like this. An illustrative example of that, again changing my screen, will be in this site where I am going to open up the Cloud Genius website in full screen mode and illustrate a point here. Let's go look at this site. And so this site is opening up, and let us look at the picture here. This guy, this guy is right click, and let us look at the image address. So I'm going to grab the image address here, copy image address, copy that, and let us see where it comes from. I'm going to open an editor now. An editor is opening up, and I'm going to open a new tab and paste that link. Let us look at the link where it came from, make it big so you can see this from a distance. And also notice that the URL on the top of this site is this. So I'm going to grab that also, put that also in the same site. Now you will notice there are two distinct places where the picture is coming from. The picture seems to be coming from another site. It's called cdn.cloudgenie.us, whereas the site itself is coming from b.a.cloudgenie.us. Now this was a scenario possible because of a change that I have made to the application and making it stateless. Let us illustrate that point one more time with another example where I'm going to grab a picture and put that in here. So I'm going to log into the site and I'll try to upload a new picture. So I'm going to log in right now, And here in my WordPress, once I log in, you will see that there is a place to add a picture. As a editor, as a person who can edit the site, I can actually go to media and add some new media here. So I'm going to say, I'm going to select a picture file and then maybe send a picture on the desktop if I might have a picture or something. Let's say I don't have a picture here. Interesting. Pictures. No pictures. How crazy. There should be some picture somewhere. There is one picture. Is it usable picture? Yeah, looks like it is. Should be okay. Let me quickly examine. So don't look at my picture. Let's see if it is. It should be okay. I think yeah, it's some God picture, some holy picture. Some random pictures came along from somewhere. And so yeah, this is my brother's daughter. So I'll take this picture. I'm going to choose it. Click. And that picture is going up online, and it went, and it is now. Let us look at the URL. Where did it go? So the picture showed up here, right? This picture is now in the media library, and you will see that this picture also shows up in the media library right there. But you will carefully notice that the link is different. It is actually this link. So let us go look at the link again, and I will paste that link in your notepad. So I'm going to notepad and then paste that link right there. So you will notice that the link is kind of a different site altogether. But I uploaded the picture to this site in line number 5, and the picture went to a different site. Now what is going on? Let us study that part very, very carefully. Let us go and examine as to what just happened. And the idea here essentially is I'm going to go back to my drawing board. And you will, I think you can remember that this URL is cdn.cloudgenie.us, then WP content and uploads and some ID. So this 1096 ID. So that's the file name. And now let us go to S3 bucket itself. This actually is a S3 bucket which goes to from WordPress. I push it away as soon as a user uploads a picture or some object. I want to keep my WordPress as empty as possible, as stateless as possible. And that's why any video object, audio objects, anything that the user uploads, I want to keep that user information, user state away from the application, and not with my WordPress deployment, not with my application deployment, but somewhere away. And so the choice I have made in my context happens to be S3. And that S3 upload automatically happens in the back. And I'll illustrate that point. I'm changing my screen again to a writing board. In the whiteboard I have here. So what I'm doing essentially is when the user, like in this case me, comes to the site called b.a. whatever site. So a user uploads this picture like this, the picture P. When the user gets uploaded to this location, the code is written here in such a way, which is a non-standard way of writing WordPress. By the way, WordPress is not written. WordPress typically writes and saves the picture right here. But that's not I would like to have. I would like to have the picture go away. So I can basically kill this machine on a moment's notice, bring a new machine at new place, and have that same thing show up in this location because I want to keep this as much stateless as possible. And that's exactly how I try to accomplish that. So in effect, what I'm doing is when I have the new picture, I will take that picture from this site into WordPress, but then actually delete the picture. I'll not keep it here, not here, but instead push this picture away to S3. And then go in a bucket called WP, whatever that name was, and then put a CDN layer on top, content delivery network layer on top, and then render that through a unique URL that I have created, cdn.cloud whatever, and that the whole thing, this same extension that follows along. And that is what you see. And then I also add HTTPS to the top. And this is what you will see when you visit my S3. So let us go do that and let us inspect what contains in my S3 corresponding to this picture that I just uploaded. So I'm going to switch my screen again, go into this time Safari, go to my console.aws.amazon.com and see if I can log in successfully. and I will need to go here and put in my second factor authentication. So I can go inside my S3 and inspect. And so in S3, I need to find that 6-digit code number. It is 295662. And now I am in. And once I'm in, I will go to S3, which is somewhere here. And then in S3, there is this bucket called Cloud Genius, which is here. And then in that bucket, there is this folder called WP Contents, which should be here. And I'll make the screen a little bit bigger so you can see. And then I will look at the uploads portion, and it's trying to upload. And then the file name was, let us see the file name. What was the file name for the user upload? The file name was 1096. So we'll go and see that exact file name, 1096. IMG, right? IMG. I. Where is I? Up on top, capital I. No? Is it month, year, or something? Let me examine that one more time. What was the file name again? It was uploads plural IMG 1096. Okay. So uploads plural IMG 1096. There it is. So this picture got uploaded right there. And the upload date and time actually happens to be like right now, Monday, October 5, 1317. And at the same time, it also created some thumbnails for me. As you can see, the thumbnails for the same picture, this one, are available here. 1, 2, 3 thumbnails of different sizes, 100 by 133, 150 by 150, 225, 300, all these thumbnails created. And the actual picture went up right here, this one. So that is the actual picture sitting in S3 that gets rendered through CloudFront, which happens to be, and I'll show you the CloudFront piece now. I will go expand it and go to the CloudFront section. And I'm going to switch over to CloudFront, in which I have the idea that I have a distribution already created for the Cloud Genius bucket. And that is this bucket.
Nilej, quick
Yes.
question.
Yes.
How do we connect this to, I lost the connection from where this fit to the 12-factor manifesto.
So
is part of the code base, is part of dependencies, config.
Yeah, bingo. It is called stateless. So the question was, how do we connect this idea to 12-factor applications? And the answer was, it is about remaining stateless. So I'm going to switch back to the 12-factor. And the idea is that you want to have your applications remain stateless. And so in one of these examples, I'll describe that. Where is that thing? Hold on, let me adjust my screen again. Where you want your application to remain stateless, so keeping states away. And the item here is process. That's the item you want to keep. That's where it describes about execute the app as one or more stateless process. That's the core idea here. Does that help?
The process,
sorry,
moving the content, is the process having a regex on the backend so WordPress can automatically send it to S3? What is the process that make it stateless?
The idea that makes it stateless is that we are not keeping the picture user-generated content. User-generated content is kept away from the application itself, away from your main application machine. So let me illustrate that point one more time here. So we will get another sheet of paper. This one is probably better. And so here I'm going to erase these drawings and illustrate that point. The point that I am illustrating is that when you have an application that you want to, let's pick an app. So here the application is maybe that one. So you have the platform, and then you have some app running, then you have some database taking care of, but you want to keep your pictures away from your main repository of applications. So if you will not have this picture going away from this location. If you keep the old way of working, the picture will probably sit here, like right there in the file system. And the user will upload the picture, the picture it sits here, and the database portion is here. That's okay. But what I'm doing is basically taking the picture away from the file system and putting that inside a bucket somewhere in S3. And so what will happen in that scenario is that initially the user will upload the picture right here in that machine. However, through some changes to the application, you want to keep that code so that the picture goes and sits here. And then you have a CloudFront layer on top that renders the picture. When the user wants to see the picture, that gets rendered like this. And that is a subtle change that allows you to do this one simple trick. And that trick is like this. I'm going to erase some of those green lines here. And the trick becomes, now that your picture is actually away from the main machine, it allows you to scale very, very easily. And by scaling, I mean something like this. Otherwise what happens is, if your picture is sitting here in this box, then this box doesn't have it. There's no picture. And this box doesn't have it. No picture. So when there's this load balancer that you have on the front end, like this load balancer user, this user, one of these users, let's say, this user, if he comes along, and then load balancer might allocate this guy to go to that machine, and the initial user, let's say, puts up his picture. So the let's say mom comes along and says, here is my picture of my daughter. So here is P, and the picture sits here. When you don't have the S3 CDN type scenario, in that case, you don't have it. Now, the mom's sister comes along, and the sister is here, and she says, okay, let me see where the picture is. And the lady comes and says, okay, load balancer, please give me a machine. Load balancer says, okay, here you go. And then, hey, where is the picture? I don't find it. Where did you put the picture? That's the question, right? The picture is missing. In this machine, there is no picture. And so if you put that picture element away from any of these boxes, not here, any of these boxes, meaning keep them away, keep them stateless, keep the machines independent of the picture of the user generated content. In that scenario, when I'm going to erase all these green lines one more time, and if you keep that picture separately allocated in a S3 bucket fronted by a CloudFront, then in that scenario, you have the mom as well as the mom's sister. Both of them might get allocated to different instances like this, and they will all be going for the same database. However, the picture will come from here to both of them. When they want to see the picture, that goes like this. When they upload the picture, mom uploads the picture first time, goes like this. And then at the very moment, without storing the picture here, you keep the picture here and erase it from that computer. You don't want it on that computer. You want that computer to be almost identical to any other machine on the yellow ribbon. The idea is to keep these machines fungible, to keep them almost identical to each other, so that it doesn't matter if one of them dies. Okay, no problem. You can bring another one. And so just copy this one, put them here, and there is nothing to lose. That's the idea behind keeping your state away from the machine. Like user generated content is a representation of state. User logging in, logging out, adding some content, or making changes to the state, all of that gets captured. Logging, logouts are getting captured in the database here. The user generated content gets shuffled out in some storage bucket here. And this CDN is actually delivering the content back to the viewer, the mother's sister. So does that get you a good perspective on what am I talking about in terms of keeping things stateless? Because it allows us to scale like this comfortably, very, very effortlessly. Because now you don't have to worry about where the picture is, right? Do you get that, Carlos?
Yeah, I get that part. The piece that I'm not connecting is this doesn't make the code base any different. So I know how to do this. What I'm trying to see is how to connect this to the idea that the 12 manufacturers, that in what area of a process, because that part doesn't connect. I'll read it again.
Okay, I'll illustrate one point. I'll maybe I'll let you read that again. But the idea is right here, processes execute the app as one or more stateless process. That's the idea. You should read further, and we can talk more about it. Right?
Okay.
Okay. Okay, that's good. So let's continue. The thing I just did is this daughter's picture sits in CDN and gets delivered to me. If you go back to our WordPress box, so I'm going to show you that one closing point on this aspect. Let me connect to my WordPress machine, and there I go. So I have now connected in this terminal. I'm making this terminal full screen and make it big so you can see the connection to that WordPress machine. If I go to that location where I have my Cloud Genius WP content folder, and here is where my content is supposed to show in terms of uploads, right? And so if you look at this thing carefully, if you look at the listing of this, I do have some things sitting here in the content in the upload section, but there is no such thing here that refers to the picture I just uploaded because that picture has been by code removed. And so I have killed that code, killed that picture from this site, keeping this particular machine, which is the Cloud Genius instance running. I have kept that to the extent possible stateless. In fact, you can see some of that change in code in here. I think that becomes a separate topic for discussion. So let's deal with that separately. But all these assets that you see in the pictures, they should actually become visible. These are the pictures on the site. They should all be visible in the terminal here, not this one, the other terminal. Where is that terminal? Yeah, here. They should all be visible, but you don't see any pictures in this listing in the uploads folder because they are all sitting in S3 through the same method that I described. Is I want to keep my application as much stateless as possible so I don't have to worry about changing anything because there is nothing actually that needs to be changed. Because anything that relates to changes, I deliberately keep them away, keep them separate in a different service, like a database service or S3, a CDN, or some other place, or a queue, like a queue service if I might have, or an email notification service like MailChimp or Mandrill or simple email service from Amazon. So any of these things, I try to keep them separate as independent services. Continuing along the same chain of thought, let me close out on this window and go back to the port binding. The idea essentially here is you interface with any other service that you have with a very, very clear method of having a URL and a port combination. So it becomes easier for you to operate either with a user accessing or an API accessing that particular service outside. And as we proceed through our discussions, we'll keep referring back to these elements in terms of concurrency, disposability, dev production parity. And that's one of the things that we are dealing right now with is the idea that we have, which is we are creating a configuration here in our virtual machine, which is going to be exactly the same configuration that I will like to put in production. And so that consistency of what you have here in your development workstation, like to keep that same thing in production. And so you build at the very beginning with the idea that everything that I have is going to go production straight. And that's one way to think about dev prod parity. Another one is about logs. How do you keep logs? How do you keep track of them? And on a large scale application deployment, how do you take them away? The logs will typically get stored on the same box. So, if you know, logs will typically get stored here. Not in this terminal. I'm going to switch terminal to the bigger terminal again. That terminal was here, this one. You will notice that the logs get typically stored in var log in this folder, and that's where logs get accumulated. And these are all the logs for a variety of things, MySQL, PHP, the whole logs. A good implementation, by the way, this is not a good implementation. In a good implementation, I would actually take these logs away from here and put them away somewhere else in form of a service. Another example of that would be Hadoop. If I have my corporate Hadoop, I will take all these logs and siphon them away into some central location where I keep a dump of all the logs that ever get created in any of my applications that run wherever they run, and thereby keeping my machines. I don't need to go back to the machine to read the logs. I want to siphon them away to a Heroku. In fact, in our group right now, there is an Expedia person, Niku. He does some log analysis, and that example would be something like Expedia.com generates tons and tons of logs every single time. Every user visits them, logs in, logs out, buys a ticket, does this, does that. Expedia will come up with pricing of dynamic nature for the user to get enticed into buying the ticket that they're buying. And for that, they have an elaborate system of logging, and they have a 4 petabyte Hadoop cluster that, one of the things that the cluster takes care of is logging. And so all of that log that comes from about 40 different properties that Expedia has gets stored inside that cluster. And people like Niku actually analyze those logs and try to make sense of what that means, and then come up with ideas in terms of what that would translate into from a business perspective, is to come up with the appropriate recommendations to the end user, making them feel comfortable buying a ticket that they may want to buy for going to Hawaii, for example. So that was about logs. And the last thing I think is about administration, as to how do you take them as one-off processes. And I would suggest reading them, and let us keep discussing that as we go along. Having discussed this aspect, let us jump back to our work we were doing, which is the Heroku exercise. We have in our example in here, we have completed up to the step where we have created a Rails application. We briefly discussed model, view, and controller idea, in which we had the discussion about a cat controller, a dog controller, and the logic behind it, and representation of cats and representation of dogs, if you remember. And then next, we ran out of time when we were about to actually create a controller. And so that's the action I want to do next, which is in my virtual machine on the other half of the window. I'm bringing it up, and here I'm going to close out on this window and go back to my terminal, in which I have the last action that was Rails new application developed. Then I entered into that application, so cd my app, and then I was looking at the app at that moment. And so that's what we have to do next, is to think about create controller logic for us. And so we are going to create a logic. Our goal of this application is to just show the time of day, not much. It's a very simple application. And to show a page, we need to have some kind of an index action, meaning index HTML should show up. And for that, we need to create a welcome controller. And this idea of generating a welcome controller is fairly trivial. And you can see that this current location in our application, you will see on the Atom editor that there is a controller called application controller, and that is what shows up in this window. But it does not have much code. In fact, there's just the boilerplate code that Rails provides. Now, on top of that code, I intend to create a new controller which will automatically generate all the code needed to make it available and usable in form of an index action. And that code will get created with help from this gentleman, DHH. And so he has already done the hard work for us, and he's created Rails. So we are going to use the constructs that he's going to provide to us by invoking a command the way he defines it. So he defines it that you should invoke it this way to create a welcome controller. And as you will see, when you run this particular action, it will actually create a bunch of code for us. And you will see that happening right now as you speak. And so you can see that Rails is running and generating new code. You can probably see in the Atom editor in the background, and also right here, it created a new application controller, welcome controller.rb Ruby code. Right there it sits in the application welcome controller. Then we have some new view created called welcome view. Then we have created a test case for welcome controller. Then we have created a helper application for welcome. We also have created some JavaScript using CoffeeScript construct. and some related CSS using SCSS. These are higher level abstracts of JavaScript and CSS. So that's what Rails is using. You can see these references in our gem file. It is an easier way to write JavaScript and CSS is CoffeeScript and SCSS. These are the pieces of elements of code that have been created and are appropriately placed in a variety of folders. You can see that happening in your controller folder. Has the welcome controller, has a welcome helper, has a view called welcome, and those elements got created. There is some style sheet generated called welcome. There is a JavaScript generated called welcome. And so these are basically dummy placeholders with some skeleton code available to us for us to use. And now let us take that next step. So with this help from this welcome controller generator, we were able to generate a welcome controller. And as we proceed along, you will notice that in the view, in our app views and then welcome view, we don't have anything. So we need to create a new view in there, in the welcome view section. I hope you can see. Is it too small or is it readable? Kind of. The view welcome section, I need to create a new file that sits in this location. And that's what I'm going to do using this command. And so I need to add this particular content to that file. And so I'm going to copy that content over from the left window, bring it here, open a new tab. And in that new tab, I will save it here. And that file needs to be saved as in the appropriate location. It needs to be going to the app and then views and then welcome, and the file name has to be index.html.erb. And this ERB is a Ruby based templating language, and you will see that once I save it, it will get created in the appropriate location as I want it to be, and that will go right in the welcome folder right there. And this, as you can see, has a very, very tiny little piece of Ruby written right there. In line number 2, time.now is a Ruby construct which will give us what time is it right now on the local user's computer. That will show up here. Once we run the index action, which will get invoked from the welcome controller, and for which we have to next define a route. A route is something that a user will see when they visit a particular URL pattern. So the basic URL pattern that we want our users to visit is the main route pattern, so the slash pattern. And that pattern, we need to make a change to the main route itself. The slash pattern is the first route that www.something.com/. That's the main root location of the site, and that's the route I want to make changes to. And for that, I need to go and look at my configuration, which is this folder. And in there, I will need to go look at my routes.rb file, which is this file. And in that file, you will see that there are a variety of routes, some defined, most of them is commented out. But on line number 6, you will notice that there is already a piece of code I can just readily use by uncommenting line number 6. And that is what I'm exactly going to do. So I'm going to go to line number 6 and uncomment that root. And what it does is enable the welcome action to render the index.html page. And so whenever a user will go to the root of the site, meaning the slash of the site, the top level page in the site, then this welcome action will kick in. And what we want welcome action to do is to show the index page inside the views portion. So that's the page we already have created in a previous step. And I'm going to now save the config routes file. What this does essentially is sets a direction. Whenever a user comes, you should show them the index page. That's what it basically, this is the index page that will show when the user visits the site. That's pretty much it. That's the app, the entirety of the app. Now, having changed that, we need to now go to the next step and understand what we are doing is to verify that the application actually runs locally, for which I need to run my app locally, for which I will use the Rails inbuilt server. Rails has a built-in server, and I can invoke that Rails server to serve my application right here on the laptop. And I will just say Rails server. And when I do that, it will start a local server. and start rendering that application right here in my virtual workstation. Then I open my Firefox browser in the workstation, and you can read that it is telling you to visit the site, and it is rendering that site on HTTP localhost 3000. So I should then visit HTTP localhost 3000, and that's where I should find my application running. And I'm expecting to see that I will see my application that Rails is running right now, and it is showing me the thing that I expected to see right now. And so that's what I expect to see. The time at this moment is whatever that time is, and that's what I'm noticing, that my application is actually running comfortably in my local workstation. Now I need to break the application from running any further, because I'm all done right now from the local development perspective, and I need to take that next logical step. So I broke my server in the Rails server, and then I proceed to the next. Now, up until now, what we have done is created a very trivial app using Rails, created a welcome controller, modified the index action, put some sample code, and ran it locally. Now we are happy about what we have, but at this moment, I think we have to do some changes. And one of them is to make sure that we are following through recommendations provided by the 12-factor discussion we just had. And for that, there is a helpful gem available, and that gem is also called Rails 12-factor. And so I'm going to include that gem in the gem file, and also make it very, very disciplined about what version of Ruby I want to run, because Ruby versions can change. I might have a slightly different Ruby than you have, and your app may not run in your machine, so I don't want that. So I want to go make a discipline and put that entry in my gem file saying that I want to use Ruby version. The one I have is the corporate standard that I think I'm trying to establish, and so that the standard I want to put together is anybody in my company will use that particular version of Ruby 2.1.5, even though it may not be the best, but it works for us. So from a security perspective, we have evaluated that it is the good one, and we are going to live with it, and that's the commonly agreed upon understanding. Then we stick to that, and everybody runs that same version of Ruby from the perspective of this particular application. You can run any other application with another version of Ruby, and all of that can be very disciplined and controlled and run in an organized fashion by deploying it like this. So you're calling it out that I'm going to run this app with Ruby 2.1.5, and then you save. And when you do that, you're basically telling Heroku, telling your colleague, telling your staging person, telling your development team, telling your test team, telling your operations team, anybody in your company, you're telling them this app needs to be run with Ruby 2.1.5. And hey, Heroku, please remember, even you will need to run this app with 2.1.5, not 2.1.6, 2.1.5. And that's what you just told them. Now, anytime you make a change to the gem file, you need to run a bundle update so that it will update the gems. So I need to go back to my terminal and update my gems, which is as simple as running a bundle update. And so when you do this, it will grab the missing gems that may not exist locally, put them all in the path, and then you should see that it is actually installed those missing gems that are required. And you will notice that this 12-factor gem was new. And so this gem, 12-factor gem for Rails, also required standard out logging and Rails serve static assets and some sprockets. Now, two of these are kind of related to what we are just discussing in the 12-factor discussion, which is to serve statics separately from the app. So meaning any picture, any imagery, any static content should not be sitting right in the application, but instead serve it from some other location. That's one of the ideas going right here in this gem. And the other one was about logging. You want to keep logging separate from the app. So if you have a standardized structure of keeping logs in a separate location, use that method. Or in the context of Heroku, we will be using Heroku logging method. So that's where you can examine the logs coming from Heroku that you will see once you actually start checking the logs when you do. So having updated our bundle, our next idea is to make sure that this database that you have, this database YAML file that you probably look at in this configuration section, it has a reference to the name called my app. And also this is okay for development, but for production, we should not have that reference. So if you go look at the bottom, there should be a production entry in line number 81, and that also we seem to have this my app reference, and this my app name comes from the fact that I created Ruby Rails new with the name my app. This name my app doesn't really have any connotation, and so we are going to actually remove that name my app from the username. So this name goes away because it is unique to my machine, and I don't want anything that is unique to my machine to be dependent to other people to be dependent on what I have on my setup. So I'm going to strike that off completely. Line number 84, I will remove, and that basically makes it similar to what other people might have. So it basically we are going agnostic, not using that name. So it will automatically pick up the username of the currently logged in user. And having done that, we will save this file, and we are going to quickly match what we have in our big database YAML with what we see on the left side. And it seems like it is matching, except some commentary left and right. There are a lot of commentary here. So we can either read the commentary, leave it alone, or just delete the commentary if you don't feel like keeping it, keep it short. And then it should actually line by line match what you have in your write up on the left side. And you can see that matching very, very quickly. As soon as I clean up these commentary, you should see that it does match. And so here we go. Now we have a very small database YAML file, and it does have the same exact construct that we have in our write-up. And I'm going to save this database YAML. So save it, close it, and then go to the next one. And you will also see one more thing which I forgot to mention, which is in the database YAML. We are actually using the environment variable called my app database password. We are not putting the password in the app itself. And sometimes developers tend to hardcode. The idea is to keep the password for the database separate in the environment. That's another 12-factor way of thinking. So keep the passwords and other credentials away from the app. So don't commit, don't put a git commit with your password in there. Sometimes, it might happen that people will. In fact, I have seen in cases in GitHub. Let's go see some of those. And I have made that mistake myself, by the way, I will admit, is that you will find sometimes people will put their AWS access key in right in a Git repository and publicly visible. So, sometimes people just put that, by mistake. They'll put the access key itself right in some Git repository and by mistake just leave it. Some example might have it, like, here is an example they did not. But in fact, this user is smart. They have put this y and z x keys and secrets. But new users tend to make that mistake and actually put the passwords right in the file, and then commit and push it to GitHub. And sometimes by mistake it's a public repository. And if you happen to lose your keys and secrets like this, it does not take too long for a hacker to grab your access key and secret and rake up $600 per hour of usage in AWS. Because what people are doing, what hackers are doing, is grabbing those AWS access and secrets, searching actively on GitHub, and then they have automated processes to start the biggest possible machines and the biggest number of them, 20 per region in every geographical region in AWS, and they will just start Bitcoin mining on your money. And that has happened to many of us, including me. Yes, I have had this happen to me a few years ago. And thankfully, I keep track. So I immediately noticed that all of my accounts in every single region, I seem to have some M2 8 extra large instances, 20 of them in every single region running simultaneously, doing I don't know what. And that moment, I figured, what, I must have made a mistake, and I canceled out the keys and invalidated them. Went manually deleting everything, called Amazon, figured out what's going on. They told me you got hacked. And the hack was basically my mistake. And so I understand. So don't do that mistake. People have done it. I have done it. And don't put passwords. Keep them in an environment. Keep them away. Keep them separate from the code. That's the idea. Having said, I will now close out on this database YAML and continue our next step. which is to store everything that we have, this one, in a Git repository. And thereby, we are able to give this Git repository to somebody else, like our colleague, our coworkers, GitHub, or Heroku. Heroku also is a Git repository in some context. What you're basically doing is giving it a Git reference. Okay, hey, here, Heroku, take my Git reference and run that unique commit hash. And that's what we need to begin doing. So I'm going to put the entire content of the My App folder in a Git repository, for which I need to make this window a little bit bigger and clear. And then I will run these commands quickly. And so git initialize right here, then add everything I have into the git commit and then commit it. And when I commit, I have my initial commit. Okay, what did I do? Oh, MA. Okay. It's just M. And I committed and then git status. So I see that everything is inside my Git repository, and I have taken that step of keeping everything inside in a revision control, and my log will give me a Git log will give me a commit ID, and that's the commit ID I need because that's a reference to what I have right now. I might change over time, things might change, but that's the thing that I know runs in my local laptop, localhost. And so having done that, let's go next. And what do we have next is we have to create a remote connection. So right now, if I'm going to quit out of the log and clear my screen and check my Git remote connections, do I have any remote connections? No, because I have this repository completely local to me right here. There is no remote connection between my application here and any other Git repository anywhere else. And so that's why my Git remotes are empty. But when I say that Heroku create an app for me right here in this folder, and also correspondingly in my Heroku account, for which I think I may have changed my password from the last time. So I may have logged out of Heroku, which means my Heroku create will not work. So I'll want to make sure that Heroku login is succeeded first before I run the create command. So for which I need to go grab my new password, which I think I changed the last time. I'm grabbing my Heroku password, new one. And there it is. So copy the password and back to my terminal. And here I'm going to type my email address and then type my password, and authentication succeeded. It also tells me there is an update available. I don't need to get it, but I can. So all you do is Heroku update and it will get the update for Heroku. That may be not necessary, by the way. So this warning update available is not a requirement. Having done that, I still do not have any Git remote. So in my example, Git remote show me verbose, and I do not have any. Now Heroku create, and this command will create an app on my Heroku account as well as here in my laptop. And so I will go check Heroku one more time and see how many apps do I have. So these are the apps I currently have. And as you will see, as soon as I create the Heroku create command, it will create an app called Cryptic Headland 5776. That new application got created in Heroku, and that should show up on the left side as soon as I refresh my browser. So this is my Heroku login. I'm going to refresh my browser and I expect to see Cryptic Headland showing up. And there it comes, Cryptic Headland right there. So that's the new app that got created. And this app does not have anything yet. And I'm going to go back to my Heroku account. And here I will check my Git remote. And you will see that it has a remote called Heroku. The name of the remote is here, called Heroku. And the link to it is this. And so this is the place where I need to push my app for it to run in that location. So it will then run, gets deployed right here in this location once I push. So I have checked my remote and I have a remote handle to my Heroku account and an app called cryptic headland 5776 there. Having said that, let's go to the next step, and that is to simply send them my commit. So whatever my commit is, just take my master from my git log, whatever I have here, git log, these logs I have only one. So take that, it also happens to be my master. So take that master, which is this one, and then say git okay, I'm still online. Okay, I hope you can hear me, right?
Yep, can hear.
Okay, good. And so here we have git. The action is to do a push and to push it to Heroku and take my master and deploy it in your Heroku account. And the idea essentially here is you can actually send another git hash, another commit hash, and treat it as master if you like. But right now we just have only one hash, so this is a good command to send. So I'm going to send this, and this will actually start counting objects and compressing them and sending it over to Git in Heroku. And now Heroku received it. It is detecting that it was a Ruby application, and that's awesome. It also detected that I have to use 2.15 version of Ruby. That's also beautiful, 2.15. And then it is looking at my gem file, and in there it has this requirement of all the dependencies defined. So that is what is being used, and it is running bundle update on Heroku machine right now. Just like we ran bundle update here, it is running bundle update there and using bundler 197 and doing all that install, but on the target machine, which happens to be this cryptic headland. And that's where the app will actually get invoked. And you will also see that it has configured the Postgres gem, all these other gems that are required as a part of Rails or as a part of our gem file with unique, specifically mentioned numbers. Version numbers are very important, as you will notice that sometimes things will work with one version, may not work with another version. So you have to keep absolute granular track of what versions work. And that is super important from a perspective of a development environment. You want to call out exactly what we know works and then write that down in form of a contract. And that contract essentially is the gem file. And that's what the contract is getting executed on the other end with Heroku, where Heroku is taking our requirement and invoking that exact same environment, and it is going to deploy in that location. So it has launching the app and then deploy the app in that unique URL that they gave us. And it has been deployed. What does that mean? You can actually open the app and just say Heroku open. Heroku open should open this URL right in the local browser, and the browser starts, and there it is. The app is running in our Heroku location right now. So that was simple, and if you will. Now on the left side, you will see that the app has been deployed. So it will show you a different status this time. It will show you that the app has been deployed. And by the way, if you have a credit card given to Heroku, you can make changes and actually scale the app very, very nicely. What does that mean? If there are users coming along, and you will see that you can add more we are currently using free machines. We can make changes to that and go to a hobby dyno if you want. And once we expand it, then after that, for $7 per month, if you switch over, it will allow you to add and scale out any number of dynos that you like by writing a simple command on the terminal, or you can do it through this visual interface where you can just basically scale the number of dynos deployed to service your application for your customers. The similar scenario on a sheet of paper would be something like this idea, which I was describing early on here, is that you want to get more machines to run your application. And so in the context of infrastructure as a service, that's what will happen is you will take a machine to begin with. Oops. Okay, something crashed. Let me reopen. And the thing. I'm opening my whiteboard again and going to that whiteboard and then killing this one. And so right at this, think of it as in infrastructure as a service scenario. I have only one machine running. In a platform context, you can think of it as a dyno running or a gear running or any other name that people might give it running. But if you pay more money, you can then add more machines like this. And so you can then expand, and then connectivity of between a load balancer and these two users coming along, or maybe a bunch of more users come along and join them, and they all want to see your application. You can enable all that very comfortably by having a load balancer take care of the load, and at the same time all these apps connect to the same Heroku Postgres database on the back end. And if you expand your code to write such that any user generated uploads, any static assets that you might have automatically get funneled away to another location, you can then have them deliver it to the users just the way they expect to be. So like the picture P I was talking about before, instead of storing it here or here or here, that's a bad idea. As simple as that, you don't want anything to be here, because another thing to think about when it comes to Heroku is that Heroku will specify very clearly that their dynos are what's the word for it? I'm trying to remember a proper word for it. Is called, the English meaning for it is short-lived. The ephemeral. The word is ephemeral. The idea behind it is ephemeral. That's the word. These dynos that anybody provides to you, or gears that Red Hat will provide, or we will create our own DACE platform as a service on top of some cloud, and those machine instances that our platform will provide to our application are all ephemeral. You can scale them the more or any number you like, grow out, shrink back, doesn't matter. But these dynos are ephemeral and short-lived, meaning you don't want to have these guys store any meaningful content. You want them to keep stateless. So your meaning or any information about it should go to either a database or some file store or somewhere else away, like a queue you might have, some messaging queue. You can maybe grab a queue there and put your items in the queue. Use that as a separate infrastructure. You can bring additional services, but build your infrastructure so that you can enjoy the benefit of scaling out and in, while keeping of the fact that your instances that you have here in the middle of it are ephemeral. And that's a key thing to remember when you're dealing with cloud machines. You want to keep them disposable, keep them short-lived, or think of it as fungible. Not really. Fungible is not the right word. Ephemeral is the right word here. Back to our terminal and what we were doing along. I'm going to go back to our write-up that we had, which is here, and put that on the side. And
Can I just ask a question?
Yes, go ahead.
I was curious, and if you're going to deal with this later on, feel free to just hit pause kind of thing, right? But with regard to that diagram that you had in terms of the whiteboard and the scale out, right? I understand that with S3 and CDN and so on, that's essentially the scaling out is provided as part of the platform as a service through Amazon, right? With, in this example here, with Postgres database that you've got at the back, how does that handle scale out?
So that's a very good question, and I should answer that. In the case of Heroku and Postgres, that database is really small, and it is not meant for scaling. However, let us go read in Heroku and their Postgres. They have a higher level of scalable Postgres deployments for money. The one we are using right now with Heroku is free, and that is kind of small and tiny and pretty boring. And so boring is okay as long as I'm learning. And so if you look at this, it's a hobby development. So I'm going to scale up, make the screen a little bit big, and you can see that I have a hobby development database here that got deployed right now. But if I can get a bigger database, I can see the upgrade instructions or go study the Heroku database offerings, and they might have for higher amount of money. they might give me a database that is scalable by itself. So I don't have to worry about database scaling. And so if I have these choices available from up to for hobby, it is free. For development, I can maybe pay a little bit more money for up to 10,000 rows. And for higher amount of databases, I think I can go, where are the create database? Oh, there. So here we have choices. You can pay them $50 a month and get a bigger database, or get an even bigger database up to $3,500 a month. And that's a fairly comprehensive. You can choose what region you want. There are only two right now, East and Europe. And so these guys run on top of Amazon Cloud infrastructure as a service, and they provide you a scalable database option running Postgres, Heroku on and so their dynos will be able to connect to this particular database comfortably, no problem. And that's one solution. If you're building your solution, there are tons and tons of database services available from multiple places, including Amazon, Google, Microsoft, Mongo, HQ, Compose.io that just got acquired by IBM. Compose.io. So IBM acquired this company, and they are giving you a bunch of different types of databases like Mongo, Elasticsearch, RethinkDB, Redis, and Postgres. So they have solutions, and you can get these solutions actually in any cloud. So I'm going to sign in, see if I can log in, and the idea is to select your cloud. That requires authentication. So the idea essentially is you select your cloud where you want the database to be sitting, and they will give you a managed Postgres database in your cloud. So you can be in IBM's database or Amazon database, Google database. They'll go there and create a database service for you. Or alternatively,
the examples that you're showing on the screen there, those are examples of scale up, right? So do any of these providers support scale out, so that if that database system goes down, then at least you can somehow load balance across multiple databases?
So I know of two companies that do, and those are here. These guys are actually doing it scale out. So here they have a Cloud SQL, and here you can get a MySQL scalable. This is Google, by the way.
Okay.
And so this is replicable. So sorry, it's too big. Okay. So it handles replication and disaster recovery built in. And so these guys do it. Another company that does it is console.aws. And they have a database service also. And they have 4 different types of solutions on database. So the relational database services you have are actually multiple AZ. So you can get started. And here you can select, say, Postgres, and say select, and say next step, and previous step, and you just missed that. And that was here. Multi-availability zone deployments. And you can even provision IOPS for the storage as you need. So you can not only scale up and down, but also out with the multi-availability zone. So in Amazon, you might have like these regions, and you can select any of the regions. And within a region, you can have A, B, C, D, E, sometimes A, B, C. And so within those availability zones, you can then have a fault-tolerant deployment of a database structure that these guys will manage it for you. They charge a little bit more money for the multiple availability zone deployments. Otherwise, the other one is eligible for free usage tier. And so this one, I think, is a very nice application that you can put to use. And they have some guaranteed SLAs if you like. And like this, there are many other companies who are trying to build out highly reliable, highly available database solutions where customers don't have to manage, because managing databases from a scale out perspective is a really hard problem. And so people find that managing your scale out of this box is the hardest, one of the hardest problems in terms of if you have a critical online transaction processing type scenario or any other type, when you want databases to be geographically available in multiple regions, that becomes a complex problem. And I know Hitachi has a solution and EMC has a solution, but cloud providers are trying to build up competitive solutions at a very, very affordable price points. And that's what you can see from Google and Amazon. And also Microsoft has a Microsoft-based solution available that you can put to use. Other companies are trying to build. I may not be aware of exactly who's built what, but we can do a research on that as to what is available out there.
But that availability zone, you don't have a scale-out solution. That is only HA.
Yes.
That's one of their actual requirements that they say. do not use the multi-availability zones for scale out. Use Redshift. There's a completely different database for data warehouse for Dynamo because
Yes.
those cannot scale past a certain level.
Correct, you're right. In fact, if you want to scale between, say, New York in one end and Los Angeles, that may not be possible. All they let you do currently with the HA solution is that within, say, Oregon region, you have A, B, and C. You can do an HA here, and that's what they currently have from Amazon perspective. If you look at, they call it the multi AZ, and that's what they currently have. They do not have what Hitachi will, or EMC will claim that you can do. And I remember that EMC SRDF. You might know of this or heard of it, and that will do this kind of a long range disaster recovery. Really geographically spread out replication of databases, but that's beyond the scope. You guys know more about it than I do. I have lost touch of that technology. So, but that scenario is not there. What you see in the cloud is what I just described with these regions, multiple availability zones. So going back to here, that's what you see, multi-AZ deployment. So you click on that, and that's what you get. And this is limited to a geography. So either you are in Oregon, or you are in Northern California, or you are in East Coast, but you're not everywhere. And that's a challenge. Yes, agreed. I hope that answers, right?
Yep, thank you.
So from your value proposition perspective, you can probably come up with something that is like a better solution than currently exists. That's a possibility you should think of. That's a possibility you can sell potentially to high-end clients like banks, for example.
Yeah, we're already working with a partner right now. It's a company called ScaleArc, and they provide exactly that kind of thing, essentially scale out for Oracle, for SQL, and for MySQL.
I heard of them. I think they're like the Valley area based Indian origin company, right?
Yeah, I think the founder is Indian, yeah.
Right. I think they came from India. I remember him. Yep. So the same company. It's a good one. Good company, I hear. I understand. Okay. So let's continue. So back in our Heroku close. Yeah, here we have a app running here. And in this context, from a scaling perspective, if you are using a paid account with Heroku, it will let you scale your application right from back to my terminal. Where is that? Here. And closing out this browser, closing out on breaking the terminal here, and on my write-up. So the write-up here goes on the next steps essentially about database migration. This step is kind of redundant because you don't even have a database to use. Actually, we have nothing in the database. It's just a time of day showing but you can still run the command. It will not do anything, but it will run. And so it is actually connecting a remote connection to the terminal running in the dyno that we have called, whatever that name was of this app. The name was Cryptic Headland. So it is connecting to that Cryptic Headland and then created a table called schema migrations and created a unique index. And then it did nothing because there is nothing to do. And because we're not using a database, but it did run the Heroku database migrate command on the Heroku target. Now, having done that, we can also check a couple of things here, like, show me Heroku processes running, Heroku process, and you can see what is running out there, and you can see that it is running a free tier, and it is running the Rails server command, the same command we saw running locally. Same thing, Rails server, and then these $port and $Rails env is defined in the environment. And so you can basically see that the same thing that we ran here locally is running inside that remote location Cryptic Headland. Now, having done that, the next idea is to open. We did open that already, and then we have check the logs. Basically this Heroku command is connecting to the remote location and showing us the logs as to what is going on the remote target machine. And you can see Heroku logs. And you can see the logs of the application as it started. You can see if there is an error happening, you can see that the error will show up here in the logs. So these logs will actually complain about something went wrong. You can see that right here. You can debug that. That's why you can do a remote connection to the target cryptic headland and do a debugging if you want to. There is nothing to debug right now. Next step is we have the idea of checking the Rails console. And this idea is basically you can get a command line access to Rails running on the remote target. So you basically, like this, you're connecting to the remote connection on that cryptic headland, that remote dyno that you have. And there you are accessing the Rails console directly. So if you want to make a quick hack, you can. This is the interactive Ruby terminal on the target machine that we have in our Heroku instance. Now we can come out of it by typing quit and moving along, which is most of these next steps are fairly trivial. The core ideas are already done. The next idea actually is to modify our gem file again and to use a production web server. And I'll probably do this quickly, but some of you have done it already. And so you probably understand this quite a bit already because you have done it. Having done that, the idea is to use Unicorn as an application server for Rails that is recommended for production usage. So I'll go modify my gem file again, which is available here at the bottom. And you will see that there is a reference to Unicorn in line number 30 already. And so I will just uncomment that one because that will allow me to use this as the application server. So I'm going to save and then quit. And then back to my terminal, I'll do a bundle update. And by that, what I'm essentially doing is asking my Rails infrastructure to use bundle update to use my Unicorn as the application server. And once it does that, I will notice that I have made some changes because it will actually use the Unicorn gem, which means I need to run the bundle update. That's what I'm doing right now. And then I need to make certain changes to my applications construct to make sure that the Unicorn web server actually gets picked up properly. And so the bundle got updated with the Unicorn gem included, which means my next idea is to create a new configuration in my config folder. So I have a config folder right there, but I do not have that file called unicorn.rb. So I need to create that one. So I can create that unicorn.rb containing this content. And this content is defined on the left side. I need to basically create that file. So I'll go create a new file, paste the content, and then I save it as my config unicorn RB. So I'll go into my app in the config location, and here I will save it as unicorn.rb and save. Now I have this file that shows up here in the config folder, and then I will close this window. And now I have Unicorn included in the configuration. As a next step, I will need to define how exactly to start the server, the new server I want to use, which is Unicorn. For that, I need to define a new file. And that file has to have a specific name in the context of Ruby and Rails. And that name is procfile. And that is with a capital P. And the content has to be not this, but what is defined on the left side of the page. So copy that. That content needs to go in here. And that is basically instructing any application server to run the Unicorn app server as opposed to the Rails server, which is natively provided for development environment. I would like Unicorn to execute my Rails application, for which I need to save this file in the My App folder under the name of capital Procfile. That's the name it is expecting. I know from Rails documentation, and I will save that. Now I have that Procfile in place, which means I need to be able to run my my app locally before I send it out to Heroku. And so for that, I need to define some environments. So I need to go my terminal and define two different environments. One of them is to echo rack env development. So that is one environment that I need to not this, cancel, clear. The environment I want to define is this one. So I'm going to copy that and then bring it here. And then the next one is to define port number 3000. So copy that, bring it here and paste. That generates a new file called .env. You can see that file .env created with 2 lines, and I need to make sure that I ignore that file. And this concept of ignoring is something that we may not have covered in the past. The idea is that I want to create a new file, which I did, called .env, but I don't want Heroku to know this. I don't want anybody else to know this. In my Git commit, I don't want to include that file. It is local only to my machine where I'm running the development environment and port number 3000. That's what I will be doing locally, but I don't want other people to do it this way. So I'm going to hide that env file from Git. And I can do that very, very simply by using a defined file by this name called gitignore. The file is .gitignore. Specifically, the name is .gitignore. It's in the root level of the Git folder. And in there, if I add any file name here, so let's say, for example, I add .env here, .env. In that case, that particular file or that particular pattern will be ignored by Git, meaning Git commit will not have that entry at all. So before we add this file, I want to actually not save it. So don't save. Go back to our terminal and check our Git status. In our Git status, you will see that I have modified my gem file. As a consequence, my lock has changed. I have also created a file called .env. I have created a proc file and a config unicorn RB file. I understand that. I did that. Yes, these 3 changes I made, new files, and these 2 files are modified. Yes, I understand. However, I'm discussing the idea that I don't want this .env file to be tracked by Git. I want Git to ignore this. And for that, I need to make a change in the ignore list. Now, ignore list is here in this folder. And so in that folder, I will now make a change. And I'll add the name .env to this folder and save. When I save, you will see that Git will now ignore my env. And I'll do a Git status again. And you will see that it has managed to ignore the env. It was not ignoring before, but now it has ignored the .env folder. However, there is a new change come along, that is this one, because your git ignore file itself changed, which is okay. We are just telling everybody to ignore everything in the git ignore. Please, hey Git, ignore everything in git ignore. That's the message. And so Git has decided, based on our instruction, to ignore the .env file, so that .env is not tracked anymore. And it has modified the git ignore list, which is nice, exactly what I wanted. So now I will have the .env file locally available to me somewhere here in this location. I have it, but I'm not giving it out to anybody because I'm ignoring it in the git ignore list. And that's the idea behind ignore, or git ignore to be specific. Having done that, our time right now is to clear this list and then do another git checkout, git commit. So after having added the .env name inside the git ignore file, I will do a git add and make sure that I check the git status again. And in here, I will see that there are 3 files modified: the git ignore file, the gem file lock, the new file called proc file, and a new file called config rb. And next, we will we have to commit this. So we have not committed, and so I'm going to commit this at a subsequent time. I have just added it right now. I still have to do the commit step, which I have not done yet, by the way. So we'll just do that in a moment. I have a couple more things to do, which is to edit the gem file and include one more gem called Foreman. And this foreman gem basically helps us in running our Unicorn server. So that gem we have to include called gem foreman. So we'll include that reference to our gem file here. And let's see if you have foreman reference already. Probably not. So we'll just put that right here and paste. And so we have added our foreman entry into the gem file. By the way, double quote and single quote doesn't matter. You can use either way. Just use consistently one way. So since the rest of the file is using single quote, I think I should use single quote. It still doesn't matter if you use a mix and match. That's also okay, but it's just a bad form. So I'm going to use it single quotes. And also on the Ruby side, I will make that change, make it single quote, and save, and then close. So now I have updated my gem file, which means I need to bundle update. And so I will do that, bundle update. So it will grab the foreman gem this time. And then I will need to do a git add, git commit one more time to include these changes for foreman. And then we go next. The next step is to again push. And so before we push, we need to run it locally. So I'll go do a git status quickly to check what has changed. Git status, and you can, clear git status. And you can see that I have a gem file again updated. I had a previous updates. I'll include that by git add dot and then git status one more time. And this you will see that I have git ignore edited, gem file updated, proc file and config unicorn updated. And at this time, I am ready to do a git commit. So I'll do git commit and dash message added foreman and unicorn and ready with the commit. Now I will do a foreman start. And this is a way to run your unicorn based web server. And so it will run the same thing, the same exact way, except our unicorn gem is running our local application at localhost 3000. And that's what we'll go and examine. So here we go, localhost 3000 should show us the same app, just like before. And there it is. Now we'll close this window. And this time, break the foreman process, which is running our production web server locally. And now, since our Git repo is already checked, committed, and all that good stuff, so we'll check a status. It is clean, which means we are now ready to push this, and we will push all these changes over. We have already committed, so that commit step is already taken care of. We'll skip that portion, and then we have to send the application to Heroku. So we'll do that this time. We are doing the same command, git push Heroku master. And this time it will look at the updated gem file, look at the gem file as instructions to use unicorn and foreman and proc file, how to invoke it, and all that invocation instruction, use of appropriate server for production usage, and also use of your foreman as a way to start the unicorn web server. All that instructions have been defined already in our gem file and proc file, and that's what Heroku will pick up. It will bundle all the things we have said in our gem file and then invoke the proc file to start unicorn gem and run our app in Heroku using the unicorn server, which is meant for production. And the Rails server, which is built into Rails, is not designed for production usage. And that's the change we are making. And having done that part, I think we are almost done with this exercise, because at this moment, what we have now is to check the log and see what process is running, and then we open Heroku and we are done. So we basically took the application and we are running it locally just like what we have, and running it on Heroku just like what we have here. Heroku open should show us the app, and you can see that the app will open. And there it is, back in our terminal. We should break this one, and come on, break. Yeah, clear. And then Heroku PS should show us the logs going on there. You can also check console and check for logs and reference to unicorn if you like. So we are going to check the logs and search for unicorn string. You will probably see that it is running unicorn. It is starting the process with command bundle exec unicorn port number this, -c.config unicorn RB, and that port number 37507 is different from the port that we are using locally in our machine. We are using port 3000. Heroku decides to use 37507, and it doesn't matter because all they do at the moment is to basically map that port internal to that particular dyno over to port number 443 for us here in this window. And so that's why you have this padlock going, and it is rendering on port number 443. That's where the app is showing up, and that is running correctly. That's exactly what we expect. And it is also running with Unicorn. You will also see one more thing, which is this command you have here is exactly what we have defined in our proc file. So if you go cat proc file, that's what you will see is bundle exec unicorn, and then bundle exec unicorn -p is the same port, but with a environment variable called $port, and that was chosen by Heroku to be this, and then -c happens to be the configuration we wrote down in unicorn.rb that we have, and that's how the app is running. Now, with having done this, I think we should take a step back and think about what we just did and why we did it. And so what we are really doing essentially is, I'm going to erase this scale arc reference. And by the way, this picture is an illustration of infrastructure as a service. So I'm not using this picture to illustrate the point, but instead I'm going to draw a new sheet of paper. And in this example, what we are doing is we are basically abstracting out this infrastructure as a service layer completely. And we are not dealing with machines, we are not dealing with SSH keys or anything like that. Instead, we are outsourcing all that trouble to a company we are using this time called Heroku, and they are providing us a platform as a service. We are giving them a contract in form of a gem file. Right? F has to be small, lowercase. So gem file. So this is the contract we give them, and then we also give them a Rails application. And we expect these guys to run exactly what we have in our laptop. And that's what we see when we go to localhost at port number 3000. And that is what we expect them to also show us running on top of Amazon infrastructure. They are doing the same thing, giving us our app in some location, some URL. With HTTPS defined for some name.herokuapp.com. That's what it shows up. And the same app that we gave them here is giving us back in form of the URL rendered to us as a service. And what we are doing is paying them money. So if you are actually scaling out in terms of number of dynos you want to have, that scale out aspect of it will work with the idea of your how much money you give them. I think they charge you $7 for a hobby dyno and a $33 for a mainstream dyno. So the pricing may have changed, but a per dyno pricing is what essentially it boils down to. So if you're a new business, if you're building a new app or you're starting out something, it's a great idea to not worry about these things and just focus on what you have here. Run it on your laptop and push it to Heroku and get it to work. Have your customers, accumulate them, make them come, make them like your app, make them pay you money. And when you actually get paying customers, you can then pay Heroku $33 a dyno, and that's not a big deal, right? When you have paying customers, you can do that. The core idea where this Heroku thing came along several years ago essentially is to take that burden away from developers, meaning developers don't have to worry about your, devs don't have to worry. Take the headache away. All that underlying thing, I don't have to worry about. Take my money per dyno and give me exactly what I have on my laptop and run it for me. And that was one model that Heroku really succeeded with, by the way, absolutely. Having done that model, some companies came along and slightly made a different approach to running the app. One of them was this thing called Google Google App Engine. And these guys come along from Google and they say, you know what, you cannot run your own app the way you want. You have to go and work with our model of using. So you have to have a method in which you will have to use our big table. We will not let you use your Postgres. No, use ours, and then it will be nice and fine and fancy. And I have burnt a lot of money on this, and I have had an application ported over from the standardized way of doing things over to this method, thinking that this is going to be a big name company, they will help us. And it turned out to be a bad idea because they have a customization made here that made me change the app for my customer. And that was a painful lesson. After about 6 or so months, we rolled the customer back to the standardized way of operating, so that it will run on your laptop. It run exactly anywhere you go. If you want to decide to build your own infrastructure and put your own platform on top, you can still do it that way. Even if you don't like Heroku for some reason, you can continue to do it that way. And this is something that it is something that I don't know how many customers do they still have, but that's the way Google likes, and Google likes doing it the Google way, and that's fine. Having said, it is also a viable solution. Many companies actually use Google App Engine and have their applications running there. Nothing wrong with that, but it just does not fit the standardized model that Heroku has put together, that EngineYard has put together, that a bunch of different companies, in fact, in the open source domain. Did I give you a list of all these names already in Slack chat the last time? I think I did. So the names of companies that are building platforms as a service, one of them is this Cloud Foundry on the right side. This is a good platform, open source, that IBM has taken and created a service called Bluemix. That has happened last maybe 8 or 10 months ago. And this is what you are seeing right now coming as a service from IBM. Basically, it is Cloud Foundry. And underlying, it is OpenStack. So under the covers, OpenStack on top, they give you Cloud Foundry platform, and then you put your applications on top. Similar to that, they have also this idea of IBM containers, which is basically Docker containers. And the company called Docker, which is now very well known for its containers, and we'll do some exercises with Docker also to give you an idea of what that technology actually means to running in a very, very nimble fashion, very, very agile fashion as we proceed along. But the core idea behind platforms as a service essentially is that you abstract your developers away from dealing with infrastructure, from dealing with setup and libraries and maintenance of patches and dependencies. You just outsource all that and pay some amount of money on a per dyno basis, and just focus on your application, get your work done, get your customers happy, and stick to that core competence. And that's where this thing comes from. So that was the exercise we did. Now, having done that, there are a question for you. There is this exercise which is a little bit more involved, and so I'm not sure if you have actually did this part. It looks very small, but it's kind of cryptic. In that you deploy your own platform as a service in Docker containers. Has anybody attempted to do this already or not yet?
Yeah, I did it last week.
Half of it, and then got through the DNS section and just stopped there because I wanted to get more background from you first.
I see. So DNS, I think, yes, you're right. In fact, DNS section is kind of cryptic, and that's where I have tried to put a picture, but the picture itself is not very eloquent. It doesn't describe to you what needs to happen. So that's where you will get stuck. And I understand. So I actually want to cover DNS a little bit before we jump into this particular exercise. So I do want to cover a little bit of DNS, but this is the exercise I want to do because this gives you a complete solid understanding of how do you roll your own service if you want to. And this is a respectable platform as a service available in open source by this company called, what's the name of the company? EngineYard. EngineYard is another respectable company, again known for its Rails offering. They started off with Ruby and Rails, and then Node.js and PHP, and now with this Days product. And so this Days product is available in open source, as you probably have seen this here on days.com. And before we jump into this, I want to do a quick refresher on this DNS thing so that all of us are on the same page. I know it can be very cryptic, at least when it comes to
Hi, Nilesh.
Yes.
Can we take a quick bio break?
Oh, yes. Thank you. Yes, please. Anytime. Thank you for the reminder. Yeah, so we meet again at the hour. So whatever that hour is for your time zone. So my time zone, it'll be about 14 minutes from now. Is that okay?
Perfect.
Yep.
And just to clarify, Nilesh, I didn't get stuck on the DNS section. We're pretty familiar with how that works. It's just I thought I'd wait to get background on the individual components and get a better understanding rather than just go and paste commands in, which I didn't see much value to.
Yeah, pasting commands is boring, right? Pasting is boring, but getting the underlying as to what's going on, what are we doing, why does it matter, how things put together, that is, I think, more interesting. And so, yes, I do have the commands written down, but that doesn't get me the excitement I want.
Right.
Yep, makes sense.
I also posted 2 questions in the Slack area just about some other stuff. We don't have to do it now, but if at some point you can let me know, that'd be great.
Yeah, that was who was speaking, by the way?
This is Ron.
Ron, okay. I'll read your questions. Okay, I don't see them. Ron. Is that a one-on-one question? Oh, there we go. There we go. So, okay. Oh, yeah. We can deal with this later on, but I wanted on the list of questions here, so don't forget to ask which WordPress plugins are you using in order to redirect images to S3 and also to public the image URL using Amazon CDN. I'll give you that exact link. If you were to use that particular plugin, does it only work with new content uploaded, or can it be retroactively applied to existing images? So yeah, the retroactive thing is a paid service. But yes, it is possible to move. Which plugin would you use in order to redirect WordPress logs somewhere else? Okay, I don't have the answer to the third one. Now let me go and hunt the answer for the first two. Okay, hunting. Hunting is actually easy. I just have them here. So I just grab the plugin name from here. So plugins that I have are, what's the name? Yeah, there it is. So this is one. Offload widget plugin site. This is one of them. Then I have one more. Amazon Web Services. This is another one. So 1 and 2. Okay. So 1.
And I assume that one of these two also does the CloudFront rewriting as well?
Yes. Yes.
Okay.
Yeah. For CloudFront, you have to do a couple of hacks on establish a. I'll show you what I did. I'll just give me a second. Let me show you the changes I did in my CloudFront so you can see it very visually. Click. Where am I? No, wrong place. Click CloudFront there. So CloudFront, and then click, and origin, you have to select the S3 bucket, and the general section you have to define a CNAME. And so here you have to define an alternative domain name and put a SSL certificate. As you can see on the screen, that's what is needed to a CDN to work like this. Do you see that, Ron?
Yep, that's it.
Okay. And then for SSL certificate, you have to get a wildcard.
Yep.
And what else is needed? The next question was retroactive, right? Retroactive. So let's go retroactive answer. The answer to retroactive is Retroactive, where is that? So here is the retroactive answer. You have to buy it, I think.
Right. Okay.
Retroactive, not free. And what was the next question? Which WordPress plugin would you use in order to redirect the log somewhere else? So here is my answer. I would not use a plugin. I would use, for a larger scale enterprise, I would use something like Splunk Storm. So here is one example. Here is another. And I'll grab those linked to you. So I'll use for logging, I'll use this Logly. And also use this may be a service, Splunk Cloud. No, this is a very expensive service though. Yeah, so that's, I hesitate to call it out. But yeah, it's a choice. But Logly and Logstash is also a good one. That's the one you should use. Logstash. That's a good one. Not this. Elastico Logstash. They got acquired? Oh, this was an open source product. Hold on. What is going on here? Get Logstash, download, GitHub. There we go. So this is what I would use for logs. I would avoid paid solutions. Use this. Logstash. It's like mustache. It has the logo of a mustache. And that's a good one. And what else did I miss? Any other questions we had? The question was, okay, the logs. The logs actually are not just WordPress logs. They can be logs about Nginx or Apache or MySQL or this or that, or you have to collect all the logs, right? Not just one application specific logs. We have to collect the whole system level logs. And so there are a variety of ways to accumulate that. And there is going to be an exercise at some point with us. We'll be using a service that you may have heard of called New Relic for monitoring. Have you heard of this thing?
No, I haven't.
Also, we'll be doing an exercise on this one, which is basically helps you a good perspective on how logging happens. And logs at all levels of all the way from infrastructure, CPU consumption, memory usage, and processes, all the way up, build up towards the application layer. So we'll do that at some point. We'll have an exercise on that. That will give us a good perspective on what logging can help with what you want to accomplish. But from a pure logging perspective, this Logstash is my favorite one. I haven't implemented it yet, but eventually when the things become big, I will probably use either Logstash or deploy my own Hadoop. And Hadoop, as you probably know, Hadoop, right? Or at least heard of it?
Yeah.
Okay.
Why you don't use CloudTrail?
Yeah, CloudTrail, Papertrail, tons of services, right? All of these services are useful. It really boils down to what the user wants. And so right now, I'm not even using my logs. They're not being placed elsewhere. I'm just letting them, sit on the server, and I'll just ignore them at time. I'll just delete them. And so since it is not that critical for me for my business yet, because I'm not getting a ton of users.
Okay.
My user base is very narrowly focused onto a certain type of people. And so I just end up engaging them interactively most of the time, as opposed to, if I'm running a large scale infrastructure, then, people will hit from wherever they have, whatever time of day they might be interested in. So that I'm not yet at that stage, meaning my products are focused products on selected individuals as opposed to large scale, what I call Amazon.com. You go buy whatever you want. It's not like that in my case. So I don't worry about logs too much. Does that answer your question? So David was going to travel to somewhere, I don't know, Europe somewhere. Did he go, or is he not online today?
He had to drop off. He wasn't feeling well.
David's not feeling well. He had to sign off early.
Right. I understand he was going to go to somewhere in Ireland, I guess. Is that right?
I'm not sure.
Okay. Okay.
Yeah, I don't think so. I think he was just not feeling well. He was a bit sick.
Huh. David shows up online. He's there. Huh. But not on Slack chat. Okay. Hey Srinivas, are you here online? Srini? Probably muted or out for a break or something. Hey, question for specifically HDS guys. Are you interested in Hadoop as such? Is there an interest in understanding a little bit of Hadoop from a hands-on perspective?
Yes, please. Yep, we would be.
Okay. So in the third segment, we'll put a portion where we'll deploy our own Hadoop in some cloud and play with it a little bit. We'll do that in the architecture section, which is a scenario where the idea of using large-scale data processing, and we'll put some of that to use. We will have something like this that you probably see on my dashboard coming on the right side, the right half of my screen is actually running Hadoop, and this is running locally here in my office. But we will be running Hadoop deployments in some cloud somewhere like Google or Amazon, wherever we feel like. And we will have some scripted methods to create a blueprint using 5 or 6 machines and allocate some disk storage and then run our own Hadoop deployment. This deployment that you see on the right side, I'm experimenting with it right now. The idea here is to be able to see if I can create something that makes sense based on, again, open source. Hadoop, as you know already, is open source, and we'll be using that Ambari, which is also a very nice looking UI. And that's what you're looking at right now here, which gives you a central dashboard of all the Hadoop related services in one place. You can just play with it as we go along. And that's what you see on the right side, which I'm going to close down and continue with our DNS discussion briefly. And so we'll do that part in just a minute. And there was a chat message. And Niku's taking off. Okay, no problem. So on the DNS parts, I will. I know some of it can be trivial, so I want to keep it quick and swift in terms of what you. If you find this is too trivial, just speed me up. But I'll take a moment to describe all the DNS related things, not exhaustive, but just make sure to touch upon the things that are relevant to us from a usage perspective. And that is what I intend to do. So the first record that I think most of us know already is this idea of sending emails. So it requires an MX record. So I'm going to go to a whiteboard here and describe this idea of an MX record very quickly. And so grabbing a piece of paper where I can write. And the idea of a record called MX essentially is it is a place where mail gets delivered. So if you have a mail coming into your domain, that's where the mail goes. It will look at the MX record and multiple priorities you might have depending on whatever numbers you put, and these servers that you call out in terms of priority order. These servers will actually receive these email packets coming to the domain. So you have your MX record defined, and you have names defined here for servers that you have from your service provider, which is running your email system. That's where the email will be destined to when you send somebody an email to that, say, XYZ domain, xyz.com domain. That's where the mail will go and sit right here on these boxes. And so the service provider for your email will give you those addresses. So an example would be like some of us in this group actually use Google Apps for a long, long time. I know at least Ron Bertino has it. So I was able to discover that very, very easily by going to Ron's site. And so Ron has a domain that I can show you. So let's go clear my screen in the terminal. I'll go dig and Ron. No, it's not Bertino family, I think. So it is bertinofamily.com and check the MX record for him. And you can find that Ron seems to be using Google Apps for work for free. I mean, yeah, that's a benefit. That what happened to my terminal? Okay, here. So Ron is using Google Apps, and you can see that Ron has defined these 5 little addresses in terms of priority order number 1, 5, 5, 10, 10, and Google has given him these addresses. And that's where any email going to Ron will get delivered to these Google boxes. And then Ron can and not only Ron, but all his company employees, or as it says, as his family members, will go to a Google domain site and then log in using their logins and passwords, and they will see their mailboxes. That's the idea. That's a very simple way to set up these records. These are MX records. And a quick test that I would like to do here to illustrate a point, which I'm not sure Ron has done it or not, but I will go and illustrate that in form of a real live email. So I'm pulling up my own email right now, a new window, and showing you this idea that you may or may not have seen. But the next idea I'm illustrating essentially is called SPF record. The idea is like MX record, like we discussed MX briefly. We are discussing the idea of an SPF record. And another key idea I would like to discuss, which is at times forgotten, is DKIM record. These are also very relevant to mail systems, and they actually are very important from a deliverability standpoint. So I'm not sure if you have set up these records, but I think from an enterprise perspective, when you are setting up mail records, or when you have a new business setting up of some sorts, or when you want to enforce security, enforce deliverability, and ensure deliverability to the extent humanly possible, you want to enable these 2 additional record types, and I will illustrate what they mean. In simple terms, what these records do is that this guy will say mailed by, and this guy will say signed by. Have you seen this thing before? So this is a signature embedded as a corresponding to signed by the domain, sender domain, signed by the domain, and mailed by the domain. That signature fingerprint shows up when you have these 2 records in place. And I will illustrate that piece just a moment, and then actually send and receive an email to Ron Bertino in his ron@bertinofamily.com email to actually illustrate these as an example. So what I'm going to do is illustrate the first point first, SPF record. And what I will do is send an email to Ron, and he will receive it in ron@bertinofamily.com. And there you will see that email coming from me is actually showing up as mailed by my domain. This will show up. And also it will say signed by my domain. So this signed by Cloud Genius will show up. And that's what I'm going to demonstrate by sending a quick email to Ron. Are you ready?
Sure.
bertinofamily.com, and I'll say hello Ron and send. So I just sent an email to Ron. Let us go check his email. And so Ron, I would like you to check your email and maybe share your screen with us, especially this portion where you click the detail. And so as you already see, mailed by Cloud Genius is already visible to me when I sent it to Ron, and that is visible. But let us look at Ron's perspective as to what you see in your email inbox, this one. And when I have sent you this email called Hello Ron, let us look at your desktop and your browser in my email that you may have now. And so I'm going to make you the presenter, and let's see what's going on. So here.
Yes, nothing's come through yet.
Okay. So we will give it a refresh, and yeah, give it a minute. It should show up. And so when it does, I will make you a presenter. There we go.
Nilesh, I'll just forward it to you.
No, forwarding is not going to work. The idea is to actually show what you see. And so forwarding, I will lose that. And so the idea that I want to see is on your screen, you should be able to right click on the little triangle, just click on the little triangle. And that's where you should see the idea called signed by, mailed by. And of course, then you can forward also. And so I will just send me an email. That works too. But I want to see these things, and I will compare and contrast what happens if you don't put these records and what the relevance of these things is. That's what I want to highlight. So please go if you can show, that will be awesome. So here is an example of an email from a company called digitalmarketer.com, and they are showing us the signed by. I think we are waiting for Ron, apparently. Oh, there we go. So here, Ron is showing us the exact same thing, which is mailed by Cloud Genius, signed by Cloud Genius. And that is possible only if you put those two records, SPF record and DKIM record. If you don't put them, you cannot have these signatures in place. So if you can just send me a quick email, reply to this one, I will see what you have, and we can then diagnose further as to how you can enable this thing. So just hit reply, and I will see what shows up on my side and take it from there. So I will now switch my presenter back to me. And so here is me becoming the presenter again. And me, right click, make presenter, and then show my screen. So I should now have an email coming back from Ron, and hello Ron. Ron says got it. And so let us click on this triangle, and you will notice that Ron does not seem to have those two records, which as a consequence, what it means is that the email that Ron's domain, Bertino family, seems to send does not seem to have the SPF record, which is why you don't see the mailed by, and does not seem to have a DKIM record, which is why you don't see the signed by his domain. And those two things are important, and here is why. They are important because, let me switch my screen over to my whiteboard. And what this SPF record is actually a very, very simple thing. It basically says, yes, it is my domain that is emailing you, not somebody else. But you know what? As a matter of fact, Ron's email are being sent by the Google domain, right? We know that already. And so we still have to make this pretend that I am actually the one that is sending. So that pretend game is played by the SPF record. And let us look at an example SPF record, what it means. So I'm going to pull up my own example of SPF records by going to my domain control panel, which happens to be in Amazon. So I'm going there, console.aws. And so my domain actually is managed under Route 53. And so in Route 53, if I click and go to the domain, and in the domain, I will look for my SPF records. And so I'm going to pull up my SPF. Where is that? SPF. It's by the way, it's a misnomer. So one more thing before I switching back to the white sheet of paper. The name SPF is, even though there is a record called SPF in the domain record types, don't use that one, because you should use a TXT record to create an SPF record. It's confusing, I know. But this SPF record that used to be in the domain control panel is deprecated. And everybody is using a TXT record to connotate SPF. So having understood that, now let us look at the TXT record. Back to our terminal, back to this window in S3, no, not S3, what is this, Route 53. I'm going to look for my TXT records. And so scrolling down, TXT, and there is my SPF records. So I'm going to grab all of that and make it a little big so you can see properly. I'm going to switch to a notepad, and here is my notepad, and there I'm going to dropping it. So here I have a bunch of different records. Let us go dissect them. And so you will see that I have broadly two records here, line number 1 and line number 2, two records. Now the second record is just a string, so we can ignore that. It is something to do with Microsoft. I'm playing with it, so I'm just ignoring that piece. And that record I'm going to delete from our view because it is not really relevant. So I'm going to delete that last line, and that goes away. Now this one line that I have is actually just one line, but just multiple parts of the same line is a representation of SPF record that I have put in my domain. What does that mean? So let us go split this line into multiple parts, item by item. Let's go at the very top. It says it's the indicator of an SPF record for both A as well as MX entries. Include this, include that, include that, include this and that and that, and be a little bit accommodative with the last line number 12. It's accommodative. Don't go really enforcing it. And that is permissive. The tilde sign before all is permissive. It can be strict if you want it to be strict, but I have kept it permissive. By permissive, please allow if there is a domain mismatch a little bit. Now, what does these lines number 3, 4, 5, 6, and 7, and 8 mean? These lines basically say that Cloud Genius domain may be sending email from number 3, Google, number 4, MailChimp, number 5, Mandrill, number 6, SendGrid, number 7, Zendesk, number 8, Mailgun. And I must admit that it is a little bit overkill to be able to send from so many different places. And that is an overkill. People or companies typically send from 1 or 2, maybe 3, not 5. And so this is an overkill. So in a typical scenario, you want to send mail of 3 different broad types. And I'm going to enumerate those 3 types of emails in lines number 13, 14, and 15. The first type of email that typically most people send are the type 1, I call them. And these are just my nomenclature, so it's nothing scientific about it. But here is the type number 1, people-to-people email. People to people. Right. Type 2 emails are marketing communications. And type 3 are machine to people emails. And so these 3 types of emails typically companies, businesses send. And there are some other types such as spam, and so we don't want that. But opted in marketing clean communications are type number 2. This is just type numbering is my own numbering. Don't read too much into it. But these 3 types of communications are people do. And so for line number 13, people to people communication, I think some companies will use Google Apps, and some other companies will use Microsoft-based Office 365, and some companies will use their own Exchange server, and some other will use some other solution, and things like that. And so line number 13, you can represent as one type of communication that company employees will do, and they will be using something like I use in line number 3, which is Google. And that's just my case. That also happens to be Ron Bertino's case. And so Hitachi might use something else. And we can find out what Hitachi does for people-to-people communication. You probably have an Exchange server deployed. I'm just guessing. Now, the second thing, which is line number 14, which is marketing communications. These are opted-in communications. People come on, sign on to mailing lists. People want to hear from your company, and you want to send them authentic, meaningful marketing communications based on an opt-in list. For that, there is Constant Contact. There is MailChimp, and there are a ton of marketing communication email systems available out there. And for that, you need a Chimp-like solution, a MailChimp-like solution, which I have included in line number 4. That includes servers.amcsv.net. Basically, is a pretend that even though I may be sending from MailChimp, line number 4, pretend that it is coming from Cloud Genius. And a third type, which is machine to people. And that messages come from my computer to you or to other people who receive email from my machines. And that I seem to be currently using this method of number 5, which is similar to Amazon Simple Email Service, if you will. So there is SES available on Amazon. And there is line number 8, Mailgun, available from another company sponsored by Rackspace called Mailgun. And that is line number 8. So I was playing with them also, and playing with number 5, Mandrill. Mandrill I've been using for quite some time. And similar to them is line number 6, which is SendGrid, another machine to people communication method. So when you forget your password, you reset your password, those emails come from a machine to person, and those methods will use some kind of an SMTP API on the back end through an external service in the cloud, which can be Mandrill, can be SendGrid, can be Mailgun. And sometimes, I have this example of line number 7, in which I use a support-based method where people will file a support case. And that has not been of much use, but I have it there. And so Zendesk is where people will come and ask for help, and somebody in India will actually respond to them based on the support requests. So somebody in the staff that we have in India will actually respond. In your case, probably nobody did because you never wanted, because I deal with support myself. I provide direct support through Slack channels. So I just interact directly with you guys. But some cases, people actually write us messages. And so in those cases, sometimes people from India respond, and those emails need to also be validated as assumed to be coming from the Cloud Genius domain, even though Zendesk may be sending them. And to enable that scenario, the idea is to put appropriate SPF records. And when you do, emails coming from Google or from MailChimp or from Mandrill or from SendGrid or Zendesk or Mailgun, but nobody else, only these 3 through 8, only these will be marked as valid sent by Cloud Genius. And that flag will show up in your screen like you saw in case of Ron's screen, like there. Like here it was showing up sent by or signed by. So those 2 flags correspond to the 2 types of records that I have here, SPF and DKIM. Let us switch over topic to the DKIM entry. And that actually involves generating a signature which authenticates against the mail server. And for that, there is a separate type of record that the mail server will tell you what you need to create. And then you have to create that particular type of record into your DNS control panel for DKIM. And that is what we are going to look at next. And while we are doing that, Ron, it will be a great idea if you can follow along with your Google control panel and identify a place where I will show you where you can generate your own DKIM and your own SPF. By the way, you can copy my SPF. I'm going to paste it. So just put that all in one line. You can copy this SPF selectively and make use of. And that, I think for your case, for your home case, I'm pasting only that portion. So that should be this thing in one line. That's what you should put as an SPF, a TXT record, and that should take care of your mailed by problem. So this will handle the mailed by scenario for BertinoFamily.com. Put this as a TXT in your DNS. That should do it. All of it in one line. Now, having said that, let us switch to the control panel, where in Google, somewhere along the way, they will give us a place to manage your signatures for, hold on, I think this Google will call me for a 2-factor authentication. So stand by, please.
Hello. Thank you for using Google Phone Verification. Remember, you should not share this code with anyone else, and no one from Google will ever ask for this code. Your code is 6121554. Again, your code is 6121554. Goodbye.
So in here, if you go to the applications and then look at the Google Apps, which happens to be the one we are interested in, is Gmail. And then in the Gmail application, go to the DKIM settings, which is right there. And that setting is called Authenticate Email. And here I have the domain called Cloud Genius, and it is authenticating my email, as you can see. So in my example, I have, in your example, you have to go and identify this particular control panel in your BertinoFamily.com, and then ask your service provider to enable authentication. And when you do that, it basically asks you to click this blue button to generate a new record. And that is what you should click to generate a signature like this. And that signature, you need to create a text record in that name. And that is what I have done. And then I come back to this page and check. And when I check, it shows me this green authenticating email method, this notification. And when I do that, I'll now compare what I have in my Route 53 for my DKIM. And here we go. I have that same exact signature in that record that I have placed in form of a text record that shows up like this. And so you will see that this item by item matches the TXT record that Google wanted me to put together. And this enables signatures at domain level. Now, why are we doing this? We do that to basically give an additional level of comfort on the recipient email server and to allow that server to not mark us as spam. Now, spam is growing, so companies have put together these methods where you can stipulate what machines are allowed to send as you. And in this DKIM method, you are actually putting a digital signature in the DNS to allow any servers that anybody who is sending a DNS, anybody sending an email to you, if you're receiving it, it should have this signature built in. And if it doesn't, then it is not signed by me. So you can spoof somebody as maybe I can spoof as Ron Bertino, BertinoFamily.com, but then the signature will be mismatched, and then Google or Yahoo or AOL or MSN or Hotmail will know that I am fraudulent because I am not matching my signature. But I know from past examples that BertinoFamily.com has a domain that actually signs its emails through DKIM method. And so this person who's apparently fraudulent because he does not have, his sender domain does not have the appropriate signature in place. So it will fail that mismatch. It will therefore is likely to get rejected. And I say likely because this standard is actually evolving. It is not frozen. Not every party like AOL and all these internet service providers, they haven't actually come to a formal agreement that we will voluntarily drop any email that happens to be actively mismatching signatures. And so sometimes this email will still go through, but it is an evolving standard where you can actually enforce. In fact, if you go look at Office 365, they currently do not have this supported. What it means is that if you, let's go check Hitachi. And so dig hds.com and mx. Let's see, where do you have your HDS servers? You're locally hosted in your company somewhere. And so probably it's an exchange, I'm just guessing. And so I'm going to go check one of your emails that you may have sent to me from Hitachi domain, and let us see. And there go. No testing, both SPF DKIM, not yet successful. Apparently, it needs some time for it to validate. Testing SPF, how about now? Not yet. Okay. So yeah, it will come, but at some point, let's see.
I sent myself an email, and the SPF is coming through, but the DKIM hasn't yet come through.
Okay, yeah, it will come. Give it a few more, maybe a couple of hours. It should pick up. It should pick up, and that will pick up, and that will make it a little bit appropriate from the commonly evolving standards in both SPF and DKIM. So you can basically improve upon what you have. That is nice. But these are subtleties in email management and email administration and deliverability in terms of what records are needed. Yes, most people end up doing MX records, but they miss out on SPF DKIM, and that's you should not miss. There is one more standard that is evolving, and that is called DMARC. And that standard is coming along in form of this website. It's not standard completely agreed upon yet, but it's coming. To make use of this is a little bit more involved, so I'll leave it if you're interested in go that direction. But there is a service available that you can start to look at, and it is free. The service is DMarkian. And so I'll leave it for you to experiment with, explain. It's very easy to understand, nothing big. But I'll just log you into that site and show you what I do with it, so that you can get a good perspective, and then you play with it yourself later. So let me log in, sign in, and allow and sign in. And what do you see here is it gives you a dashboard of how emails in your company are coming in, flowing out, and there are some red areas here, and that red area is actually showing me as an SPF error. And what the error is, let us read that. And so it's more like a health dashboard of your email system across your company. Think of it that way. And so it says that too many DNS lookups. That's the complaint. And I agree. Yes, I agree. And I think I must have voluntarily said that I'm probably doing an overkill in putting so many different domain email sender machines as a part of my SPS record. It is an overkill, and I agree. And that's what this is complaining right now. DMarkian is complaining that you have too many DNS lookups. 16 is way too much. 13 apparently is good, according to DMarkian. And they're asking me to pay attention and all that good stuff, but I'm ignoring them. I understand it, but I still ignore it. That's fine. Now, from a DKIM perspective, it's showing me all good. For a DMARC perspective, I have a P equals none. And what does this mean is that, by the way, DMarkian, now you just saw the whole view as to what I see in my domain for DMarkian. But the core idea behind DMarkian is that the standard is evolving so that any ISP receiving an email will actually report out every week or so to the domain administrator what emails come along, how are the SPF doing, how is the DKIM doing, and what's the overall volume, how many getting spammed, flagged. And so you get a health statistics across your domain for all the senders, all the receivers, and things like that. Now, those emails, you either choose to receive it yourself in your inbox as an administrator for the domain, or instead send it out to somebody who is going to compile and collect and aggregate and show you a beautiful dashboard like this. And that is what DMarkian does, is that you look at this particular DMarkian info for Cloud Genius domain, you see that I have put another record called DMark1 with a RUA mail to, and I'm sending my aggregate report emails over to DMarkian. So this DMarkian will basically receive XML reports from every ISP that receives or happens to receive emails coming from Cloud Genius domain. And they will give me that aggregate statistic either in my inbox, but I don't want to read that. So I just push it away to them. And so if you go now look at my Route 53, and let's look at the DMarkian record, there should be this one. And I'm going to make it a little big so you can read from a distance. I'm going to put that in a notepad, and here we go. So what you have here is only one line actually. I'm breaking into 3 parts. Actually, 2 is enough. So this part, line number 3, is the mail to location. And that address is assigned to me by DMarkian as a place where DMarkian.com will receive all those aggregate reports that seems to be arriving in my inbox from a variety of ISPs who aggregate statistics about how am I doing in my domain, how are emails doing in my domain. And that begins once you put the DMarkian record or DMARC record in your DNS. Because anytime you have the record in place, then ISPs will expect to send you that email summary, and you will receive that in your inbox. And in fact, I might see, from long ago, I used to have those. Let's see if I can collect some DMARC. Give you an example of a DMARC email. Okay, yeah, here. So here is a PDF summary. Now this is coming from DMarkian. I don't want that. I may have deleted those XML files, so I wanted to show you those. But this is the DMarkian summary generated for last so many weeks, probably more than weeks, where it is giving me a picture of what's going on this dashboard for my domain in terms of health of email systems across the board. So in short summary, play with DMarkian. It'll give you a good perspective on what this does. And from an email perspective, we have MX records. We discussed SPF and DKIM, and also this new type of record that's evolving, DMARC, which is going to give us some aggregate statistics in terms of how the health of the domain from an email perspective is going on. That will give you additional insights in terms of how a business email system is working for a given customer or given company or your own company. So it's your choice. Somebody pinged me on Slack. Let's see what is he saying. Patrick says, I need to drop. Can you let me know? Yes, I will tell you, Patrick. Go ahead. If you need to go, please. I'll email you that or chat with you. And so that's what we just covered about email. Let us switch the topics to a little different type of record. You probably already know that's very, very trivial. Is the A record, right? A record, most of you know already. It's like, the White House, right? The White House is the friendly name for an address called what's the address for the White House? Some Pennsylvania Avenue, 1600, yeah, 1600 Pennsylvania Avenue, Washington DC. That's the address, and so people call it the White House, and that's pretty much it in terms of A record. You have a machine which has an address, and the machine address can be whatever you want the machine address to be, whatever the provider of the machine gives you. That's an IP address pretty much here. So 192.168. whatever. That address becomes a machine in my office here. And so that address space that you have can be a target address of the machine. And to that, you can assign a name, a friendly name like the White House. And that becomes a friendly name for that machine itself. So in my example, I have some machine called Cosmos defined in the Cloud Genius domain. And that's a very trivial one. I think this example called the A record is very, very trivial, very well known. So I'm not spending too much time on it. But if you have any questions, feel free to ask on A record. The other type of record is like the thing called CNAME. So it's you probably know this already also. It's also very trivial. And I simplify it to be saying that, for the person called William, we have a CNAME called Bill, right? And for a person called Richard, we have a CNAME called Rich, or sometimes there's another CNAME called Dick. And so that's the idea behind CNAMEs. You basically select a shorter, friendly name for the longest name. So it's an alias. That's a CNAME. Let's look at some of the other record types. Where are those? There are tons and tons of records, but I'm just focusing on those that are relevant to us and relevant to us from what we are going to deal with. So mostly we'll have A records, we'll have some CNAME records. We have also this thing called name server, which is also important. And that I sometimes, go have fun with it. And so the way you can have fun with these name records is like this. So I'm illustrating a use case right now. A use case with name servers. So it's like this. I'm going to grab a piece of pen, and the domain I'm going to illustrate that point with is this same domain. And at that level, we have a bunch of name servers defined. 1, 2, 3, 4, any number of them. So that company that defines it will give you some addresses which you will call as your name servers, 1, 2, 3, 4, 5, any number of them that you might have. And you need to provide the name seller. The seller of this name needs to know where the name server is. So this is the name seller company. This is like GoDaddy. GoDaddy, no, GoDaddy, GoDaddy. So this is GoDaddy, and that company is the name seller, for example, but they need to know what name servers this domain will be using. And so then you can take these names of servers and give them to GoDaddy, and then you can then define your zone record in this name server. In my example, I actually don't use GoDaddy. I have another company called Namecheap, which sells me a name. And so they have these name server entries. And the actual name servers are from Amazon Route 53. And that is where I put my zone file. And so what you see, my zone file happens to be in the browser window right here is my zone file. And I have only one zone, and that is this zone called the Cloud Genius domain. And I have public 95 records. And that is the current state of my zone file. Now you will see that the name server records are all these 4 ones. Then copy that, put that in a bigger sheet of notepad and paste. So these 4 servers are geographically distributed by Amazon, gives me the name server that Amazon gives me in form of Route 53 service. And then they in turn allow me to manage my zone file for the domain, this one. Now the game that I like to play, and that's the game we will be playing with this DEIS exercise we'll be doing shortly at some point. Probably not today. It's like, yeah, we already timed out. But the game with DEIS is that since I don't want to mess around with my main domain, this one, I don't want to touch it, but I still want to have a dynamically allocated domain. So what I actually did for DEIS is to create a subdomain like this. And then I defined this domain to be a different name server hosted this time with Google. So it's craziness at probably extreme. And so what I have done here back in my Amazon control panel is, you will see, is that, where is Amazon? In Amazon control panel, you will see that there is this hello defined as name server. And the name server references are pointing to Google. And that's the crazy part. Now, why am I doing that? The only answer to it is because I can. There's no other logical reason, no logical reason to doing it this way. Just because I can, I'm just illustrating the level of complexity you can take it to, but probably nobody would do it this way. But I'm just trying to illustrate a point that you can. You can go and segregate multiple subdomains from completely different providers, just like I'm illustrating right now. So you are looking at these entries right here, and the Hello Cloud Genius domain points to these name server entries in Google Cloud DNS. It's a different game, completely different game. The same top level domain goes to 2 different parts. One of them is hello.cloudgenius, and the first one is just Cloud Genius. And those 2 are managed by completely separate providers. And the name seller happens to be Namecheap, which is the third company, completely independent of these 2. So the company that sold me the name is namecheap.com. That's where I got the name from, the top level name. And then let's go also look at my Google domain DNS as well. And the idea behind doing it this way is that it gives me another place to illustrate that these 2 are completely disconnected, disjointed. They have really nothing to do with one another, except the name server, which happens to be lines number 10 through 13 mapped to line number 8. And this happens to be sitting at the top level domain, which is Cloud Genius, which happens to be managed by Route 53 in Amazon. And then anything below that domain called hello dot will get managed by Google Domains. And let us go look at the Google control panel for that. And that's where you will see what we are trying to play with in DEIS, the next exercise. So I'm going to open my Google control panel right now. And here you will see that I am going to go to the, where is that? Google networking, cloud DNS. No DNS? Oh, did I kill it or what? I must have killed it. Hold on. Let me bring it back. So I'm going to refresh my page. I just undeleted something. And then I'm going to go to this project. And there I should find my cloud DNS. And there it is, the zone file called Hello Cloud Genius. And that's my zone definition. I'm going to make it big so you can see from a distance. And so here, what I'm doing is basically creating zone descriptions for a subdomain called hello. And here I have identified an A record, 1, 2, and 3 for 3 distinct machines, 1, 2, and 3. These machines can be anywhere you want. It doesn't even have to be Google Cloud or Amazon Cloud. In fact, in our example, we'll use a third cloud, some other cloud. And so these machines are references to A records in some machine somewhere. And they're just names. These controller number 1.hello.cloudgenius. These controller number 2.hello.cloudgenius. And number 3. So the 3 names, that's it. Nothing much here. The somewhat complex entry is actually this star.hello.cloudgenius. And this is a multiple IP address A record. And that is what is needed for us to then create something like Heroku did. And what did Heroku do for us? Let us look at that. So we had an Heroku example. We'll go to Heroku. And in Heroku, we had that some app called, what was that? Cryptic Headland, right? This Cryptic Headland came along for us. So we will go copy that name. And so Heroku was able to generate a new application for us called, I'm going to get a new sheet of paper, crypticheadland.herokuapps.com. And how are they able to do it? And how are they able to scale it? Because they have a record in the DNS somewhere called star.herokuapps.com. And that they were able to dynamically allocate to us based on a name that they decided to generate on the fly when we create an app for our Cryptic Headland. And that is what is going on right now, which we have in this scenario, line number 3. If you take that back, this concept over to our Google Cloud DNS, you will see the same thing like shown here in this entry. I have this asterisk.cloudgenie.us, which is basically a catch-all wildcard A record entry mapping to 3 different IP addresses, which are the 3 different boxes we'll be using to run our own platform. And when our platform kicks up, it will then dynamically allocate some random name like this Cryptic Headland 5776, and then assign that on the fly to an app that we will deploy and see on our own hello dot. That's what you will see when you see it, when it goes live. And so it will show up something like Cryptic Headland. We might have some I don't know what funny names comes up, but some random name will show up that will show our app running like this in line number 3. That's what's going to happen. And that will be enabled with a wildcard DNS for A record that we will be putting together in that exercise that is going to come up. And that looks like this. And it might vary the way it looks from provider to provider, but the concept is this. So does that give you a good perspective on what DNS records that we will be playing with? And yes, DNS can be expansive and lots of different types of records. And I did not even cover all of them, but this at least gets us the point where we can start to make use of these things in the context of what we are trying to play with. Does that help?
Yep, that's good.
Cool. So I think we are approaching like 10 more minutes. So we can either discuss a topic of your interest, or I really I'm okay with starting the new set of exercises, but I'll let you play with it. So we have this exercise ready for us to play with. And that is what I think we want to do next, which is this one, which is, no, not this one. Cloud technologies, the very last item in the list, which is deploy your own platform as a service in Docker containers. And that should be doable now that I have clarified the DNS part. The rest of it is fairly trivial, and we'll do this the next time. With the with this in mind, I suggest that you please, maybe today or tomorrow, whenever you find time before the day after, when we do this, give it a shot, give it a try, see how it works out, and otherwise we'll walk through this particular exercise that day when we meet, which is Wednesday. In the meanwhile, if you have any questions, please go ahead.
Nope, all good.
Okay. Yep. And from a question that came up on chat was, what will we cover next time? The answer was that I would, before Wednesday, I would like you to try this on your own. On Wednesday, I will begin describing this. We'll also cover a little bit of what Docker is and how does it put to use. Docker is a technology underlying where this thing will run, and we'll actually create Docker containers and then deploy a platform as a service on top of those containers, and then create our own PaaS, and then deploy an app on that PaaS. And then at the end, the app will show up somewhere like, this example of yeomanvineyard.hello.cloudgenie.us. Like, for example, I did the last time. That's where the app will show up. And you can say "Ds open," and it opens up the browser and shows you all that good stuff. So that's what we plan to cover the next time. And if you have ample time, like all of you do, you have nothing else to do in your day job. So you should read this module number 11, which is data center in the cloud. And I know some of you know this already, but it'll be a good idea to just go over in terms of some of the security aspects and networking aspects. And yes, we'll cover it next time when we meet, the time after next when we meet, depending on how much time it takes. But I will walk you. There are subtleties involved in terms of understanding security, subtleties involved in terms of understanding networking, routing, flow of application traffic, and things of those details. I will walk you through that. There are some videos already in module number 11, so that if you find time, review that, please, and give this day's one a shot as well. And that's what we plan to cover Wednesday.
Okay, sounds good.
Thank you, sir.